Hello friends, in this video we are going to look at a newly appeared problem 2962, count subarrays where max element appears at least k times. In this video we are going to explain a method for doing simple counting and solving this problem. So in general, this problem can be solved using two-pointer sliding window method. You can try that method or technique. But here we feel that the simple counting strategy is much easier to understand and digest. So our goal will be the following. First, we are going to digest the requirement, which is very short. And then we look at the coding, and roughly we walk through one example. And finally, we finish the coding and make some comments. So now let's look at the problem digest. So here we are given an integer array called nums and a positive integer k, right? So we want to return the number of subarrays where the maximum element of nums, the whole array, right, appears at least k times in that subarray. So here are two examples. Let's first look at the second example. So this example, we have 1, 2, 4 are the unique numbers, but they don't appear 3 times, so we are going to return 0. So actually they appear less than 3 times, I would say. So this is the example 2. In example 1, so the maximum element will be 3, right? In this case, we have 6 valid subarrays. So actually in this problem, it lists all the possibilities. We are going to analyze how we get those lists. So with that said, let's also look at the constraints. First is the length. The length can be as long as 10 to the power 5. So this number is large enough so that we need to think of time complexity when we solve this problem. The last one is that k is greater than or equal to 1 and less than or equal to 10 to the power 5. So this is an consistent assumption, right? Especially k is greater than or equal to 1. So with that said, we are ready to look at the logic, right? So I'm going to cook up one example myself because I feel both example 1 and example 2 is not that general. So example 2 maybe we regard it as a special case or edge case. So here I'm going to work with this list. I call it capital A just for convenience of writing. So the maximum element in this element is in this A is 3, right? So we want the subarray contains at least 2 3s. So here we know, as we mentioned, the indices for the 3 is given by 1, 3, and 6, right? So overall, actually, we just need to focus on the indices of the maximum element in the list. So here the indices is given by this list, 1, 3, 6, right? So then each valid subarray will have a start index. I'll call it L, and also it has a end index. I'll call it R, right? So the strategy will be the following. For each index R, we want to count the starts L, such that in this range, so it's corresponding to a valid subarray. Then we just increment the counting. So here we notice that we have the indices list is the length is 3. It means we have more than 2 elements, right? Then we are going to look at this one, 3, index 3. At this index, and also include the 2 with value 1s, that is index 3, 4, 5, right? In other words, starting from 3 and ending before 6. For these 3 indices, so we can have start to be 0 and 1, right? Because if you start from 0 and 1, you will include the 2 3s at index 1 and index 3. No more, right? You cannot start from 2. So in this case, we have 3 times 2. 3 means this 3 indices. 2 means 0 and 1, right? So this contribution is 6. So next we consider this indices, or this 3, right? So from this 3 and to include this 2 1s as ends, so that is indices 6, 7, 8. So we can begin from here. So 0, we can start from 0, we can start from 1, we can start from 2, and we can start from this 3, right? no more. If you make the L larger, so you will have less 3's. So in other words, so we have 4 possibilities. That is 3 plus 1 actually, right? So we have 3 next right possibilities, and we have 4 left possibilities. Then 3 times 4 is 12, right? So 6 plus 12 is 18. So the return for this example is 18. Similarly, you can analyze example 1, which is much easier than this one. So with that done, basically I hope you have grasped the main idea. Then basically we just need to format and code this logic in here. So now let's first do the coding, and then we do some tests. First we can get the max, right, of nums. So this is super easy. And then we can get the indices. So the indices will be I for I, y in enumerate nums if y equals capital M, right? So in this case, we get all the indices. So now let's do a edge case test. So corresponding to like example 2, right? So if length of indices is less than k, let me just return 0 because there's no valid subarrays, right? So next we consider general case. So we don't need to do lots of coding. We just need to compute the sum, right? So for the convenience of treatment, or we can treat it uniformly, I can append the index at the beginning with a 0, right? And also I can append the length of this list, right? But I don't need to consider these 2 indices. So we are going to iterate. So let me first initialize a result variable, and then we're going to iterate. So this result variable will be a counting variable, counting how many valid subarrays. Then for I in range, say k, right? Because we need to have at least k capital M's, right? So we start from index k. So this corresponding to, for example, here k equals 2, right? So we want to start from here. So adding a 0 in front corresponding to using van indexing, right? So if you add 0 here, let's see, you will have 0, 1, 3, 6. So the length of this one is 9, right? If you add none. So we are going to start from, we just need to check 1, 3, 6, right? So what we are going to do, start from k, and the length of indices minus 1, because we don't want to include last one, right? So because we include 2 more elements. Then we look at the possible right ends. So this is nothing but indices I plus 1 minus indices I. Think of here, right? You have 3. The possible right indices are 6 minus 3, right? 6 minus 3. That is 3, right? And then the possible left will be this one plus 1, because we can start from 0 and ending at here. So this is the left possible right ends. The left end will be indices, so I plus 1 minus k, right? So if your k is 2, for example, then you do say k plus 1, that is 3. 3 minus 2 is 1. So you're going to have here. Then this one adding 1, right? So you're going to have this one, right? So actually, basically we don't even need to add this 0. But yeah, let's do that. Let's using this one. So here we adding this one basically just to use the length minus the last available index 6, right? So now let's increment the result by the possibilities for the right ends, the left ends. Then we just need to return, right? Before we make any comments, let's first do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So again, this comment, so you can choose not append add 0 and the length, right? But this is just you need to adjust here and here. So this is nothing essential. This is the first comment. The second comment is that in this problem, so we require that the maximum of the full list appears at least k times. But if you require that the maximal in the subarray appears at least k times, so the latter will be harder, right? I would say the problem assumption makes the problem itself easier, but you could try to solve the latter, right? In other words, the maximum of the subarray appears at least k times. In that case, the maximum will be a dynamic one, right? So this is the second comment. The last comment, or the third comment, is that for this problem, we can use two-pointer sliding window trick, but that I would say a little bit different in thought process. And personally, I feel that for this problem, doing the counting here by retrieving the indices for the maximum element would be much intuitive and much easier, right? But overall, if you think a little bit deeper, so the formats of coding are different here and the two-pointer sliding window method, but the logics converge to, essentially they are the same. With that said, I guess that's about it for this video for this simple counting idea. So as we mentioned, two-pointer sliding window method here. So in our channel, we have a two-pointer sliding window playlist, which contains a large number of problems from LeetCode. So you can check out those problems to practice the two-pointer sliding window trick. With that said, that's it. Thank you.